Alright, so this section is going to talk about the double angle, the power reducing, and the half angle formulas for trig functions. They are pretty much exactly what they say. The double angle formula is a formula that takes a given angle theta and calculates what the sine, cosine, and tangent of 2 theta would be. Power reducing, that's used to break powers down, such as if you've got something like a sine to the 4th, you can break it down into 2 sine squareds, and then the 2 sine squareds can be broken down, and you can get it down to a sine of a single power that have multiple angles, and you'll see what we're talking about, because I'll work one of those out. And half angle formulas, where you're finding using a given angle or a given sine, cosine, or theta value to find the sine, cosine, or theta value of 1/2 of that angle. Now, these are not only used just to find specific values; they're also are also used to rearrange and express formulas in different ways or equations in different ways, so that different things can be done with it. One of the things in particular, power reducing formula can be used a lot in calculus to actually take a powered, like a sine to the 3rd power. That's not as easy to take to do some calculus on as a sine of 3 theta or a sine of 5 theta. So the power reducing formula actually helps you to break that down into a single power so that it's easier to do calculus on. Alright, so the ones we're going to start off with are the double angle formulas, and here they are. You got sine 2 theta equals 2 sine theta cosine theta. Cosine 2 theta is cosine squared theta minus sine squared theta, and tangent 2 theta is 2 tangent theta over 1 minus tangent squared theta. Now, once again, these are not things that I'm going to expect you to know. I'm going to give you these on the test, or I'll let you have a formula sheet. I haven't decided which yet. But you're not going to have to memorize these, so don't worry. Alright, now if we have a sine theta, which is 5/13, and theta lies in quadrant 2, find the exact value of each of the following: sine 2 theta, cosine 2 theta, and tangent 2 theta. Now here's a hint. We're going to begin with a sketch that illustrates that sine theta equals 5/13, which is y over r. Now I drew it this way because we're in quadrant 2, and we can imagine our coordinate plane here, and there's our theta right there. But our y and our r are still going to be the same. So there's my 5, and there's my 13. And when I calculate this, the whole quadrant 2 thing tells me that this is going to be a negative number. It's going to be a negative x value. Now I know that Pythagorean triples are 5, 12, 13. And if you don't remember that, you can always solve it. And 13 squared is going to be 169, 25 there, plus b squared. When we subtract 25 from both sides, we're going to get that b squared equals 144, which means that b equals 12. Now in this case, our 12 is in the negative x direction, so it's going to be a negative 12. So sine theta is 5/12. Cosine theta, adjacent over hypotenuse, is negative 12 over theta, over 13, sorry. And then tangent theta is opposite over adjacent, which is negative 5/12. Now we want to use these equations that the formulas we just looked at and this information to find what sine 2 theta, cosine 2 theta, and tangent 2 theta are. Alright, so for sine 2 theta, we have the equation 2 sine theta cosine theta. So in this case, when we plug our values in, we're going to have 2 times sine theta, which is 5 over 13, times the cosine of 2 theta, which is negative 12 over 13. So now we're going to multiply through. We got 2 times 5 gives me 10. 10 times negative 12 gives me negative 120. 13 squared, or 13 times 13, gives me 169. Now you can reduce that if you want, if it will. I don't think that's going to reduce. And then we've got cosine 2 theta, which is cosine squared theta minus sine squared theta. And when we plug everything in, cosine squared theta is going to be negative 12 over 13 squared minus sine squared, which is 5 over 12, 13 squared. And when we square both of those, we're going to get 144 over 169 minus 25 over 169. And we do that subtraction. 144 minus 25. 144 minus 5 is going to give us 139 minus 20 more is going to give us 119 over 169. All right, and then tangent 2 theta is 2 tangent theta over 1 minus tangent theta. And we've got our tangent theta we found up here is negative 5 over 12. We're going to have 2 times negative 5 over 12 over 1. Sorry, this is squared on the bottom. 1 minus negative 5/12 squared. Separate these so they don't get compared. So when we put everything together, we're going to have negative 10 over 12 on top. Negative 5 over 12 is going to give me 25 over 144. 1 is 144 over 144. And we do our subtraction there. We're going to get 119 over 144. Keep, change, flip. So we're going to end up with negative 10 over 12 times 144 over 119. 12 and 144 will reduce. So we end up with negative 120 over 119. All right, so that's all it is. Once you find your key values here, you use that to find out what your values are. You're just going to plug and chug into the formulas that you're going to have. So don't overcomplicate it. Find the stuff up here using a triangle, and then just plug it in and simplify. All right, so find the exact value of 2 tangent 15 degrees over 1 minus tangent squared of 15 degrees. Now, this is where you would recognize things, and we're doing tangent of 2 theta equals 2 tangent theta over 1 minus tangent squared theta. And then in this case, what do we know? We got 15, 15. So that's 15 here is my theta. 15 here is my theta. And then over here, what's 2 times theta? Well, if 15 is theta, and I'm looking for tangent of 30 degrees, and the tangent of 30 degrees, remember, is just sine of 30 degrees over cosine of 30 degrees. In 30 degrees, the sine is going to be 1/2. The cosine is going to be square root of 3 over 2. Keep, change, flip. We got 1 times 2 over the square root of 3 is going to end up with 1 over the square root of 3, which simplifies to the square root of 3 over 3 when you rationalize. And guys, all I did right there, you're having trouble, I multiplied by the square root of 3 over the square root of 3. Square root of 3 times the square root of 3 gives me this 3. 1 times the square root of 3 gives me the square root of 3 on top. Now, the cosine 2 theta actually has a couple of extra ways that you can do it, and this is just using the Pythagorean identity of sine squared plus cosine squared equals 1, and you can just substitute some stuff in. But here are 2 other ways that you can do this. Cosine 2 theta, the one we've already looked at. Cosine 2 theta, the one with only cosine. And cosine 2 theta, the one with only sines. And guys, all we're doing here, the way we get these is, remember, we've got sine squared theta plus cosine squared theta equals 1. All we're doing is we're moving these back and forth. So cosine squared theta equals 1 minus sine squared. And that's all I did right here, is in place of cosine squared, I put 1 minus sine squared. And then what's negative sine squared minus another sine squared? It's 1 minus 2 sine squared. That's all this is. We're just plugging it in and simplifying a little bit so that it's either all cosines or all sines. Alright, so we can use the same idea and the same identities and the same formulas to verify different things. For instance, this one is a little more complicated than some of the verifications we've had, but it's not too bad. And this is one of the few times where I'm going to say you probably want to start with the more simplified side. And the reason why is because of the 3 theta. That kind of gives me a hint that I want to start over here, because I can break that down in different ways. One of the ways that I'm going to do this, let's go ahead and get started. Cosine 3 theta is going to equal cosine of 2 theta plus theta. And that's coming directly from our sum and difference formulas from 5-2. We know that 2 theta plus theta is going to equal 3 theta, therefore we can write it like this, and then use the sum and difference formula to write this as cosine 2 theta times cosine theta minus sine 2 theta sine theta. Now, all that comes directly from the sum and difference formulas, like I said, from 5-2. And all we're doing is we're just expressing it in a way that's going to knock this thing down a little easier. Now, we've got cosine 2 theta and sine 2 theta. Those are things that we can actually deal with now. So we know cosine 2 theta can be written multiple ways. I'm going to write this cosine 2 theta in there in a way. Matter of fact, let me do this for just a second. We're going to underline there with blue and there with purple. And what I plug in, I'm going to write in that color. So that's why I'm doing that. All right, so cosine 2 theta, I want to express it in terms of cosine. So cosine 2 theta is 2 cosine squared theta minus 1. So 2 cosine squared theta minus 1. That's just going in place of this cosine 2 theta here, times cosine theta minus, and in place of the the sine 2 theta, I would write 2 sine theta cosine theta, because that's the equation we know is equal to sine 2 theta. And then I've got the sine theta that I'm multiplying by as well. Now I need to distribute this cosine theta through over here. When I do, I'm going to have cosine theta times 2 cosine squared theta, which gives me 2 cosine cubed theta. Negative 1 times cosine theta gives me minus cosine theta. When I simplify here, I'm going to get negative 2 sine squared theta, sine theta times cosine theta. Alright, and notice I'm still not where I'm at, but I'm also a lot closer, but there's a problem here. I've got a sine squared theta. Well, I can deal with a sine squared theta because I know from the Pythagorean identity that sine squared theta is equal to 1 minus cosine squared theta. And once I plug that in place of this sine squared theta, it's going to look a lot nicer. So we've got 2 cosine cubed theta minus cosine theta minus 2, and in place of this thing, I'm going to put 1 minus cosine squared theta. I am putting it in parentheses. The reason I am is because I know I've got to distribute to that. And then I've got the cosine theta that's also multiplied times that. So when I simplify this is already simplified, so it's 2 cosine cubed theta minus cosine theta. Distribute this 2 all the way through. Negative 2 times 1 gives me negative 2. Negative 2 times cosine theta gives me minus 2 cosine theta. Negative 2 times negative cosine squared theta gives me 2 cosine squared theta times cosine theta gives me plus 2 cosine cubed theta. So now when I combine all my like terms, I'm going to have 2 cosine cubed theta plus 2 cosine cubed theta. That gives me 4 cosine cubed theta. And negative cosine theta minus 2 more cosine theta gives me minus 3 cosine theta, which is exactly what I started off with to set equal to up here. So I have verified this to be correct. Alright, now we have the power reducing formulas as well, and all we're doing here is this is a way that we can break this thing down. And what we end up doing is by increasing the multiplier of the angle theta, we're decreasing the power. And this is used a lot, I think I mentioned it earlier in the video, to be able to integrate things that are more difficult to integrate. You can simplify the expression down and deal with it that way. So write an equivalent expression for cosine to the 4th x that does not contain powers of the trigonometric functions greater than 1. Alright, so we're going to start off with cosine to the 4th x. That's nothing more than cosine squared x times cosine squared x, because remember all you're doing Base, if you're multiplying the bases, you're adding the powers. 2 plus 2 would give you 4. And then I can do a direct substitution of this stuff here into that. So you're going to end up with 1 plus cosine 2 theta over 2 times 1 plus cosine 2 theta over 2. Now, I can't leave it like this. I've got to actually multiply it. So you're going to have to FOIL what's on top. You're going to end up with 1 plus 2 cosine 2 theta plus cosine squared 2 theta, and that's all going to be over 4. Now we can go ahead and we can divide that 4 into everything. So I'm going to have 1/4 plus 2. Well, let me go ahead and write the 1/4 out front. 1/4. Let's do it this way. 2 cosine 2 theta over 4. I'm going to reduce that in a second. Plus, and I'm going to write this as 1/4. 1/4 cosine squared 2 theta. So this I can reduce. I can take that down. But over here, once again, we want to write this that does not contain any powers greater than 1. So this is a power of 2, so I'm going to have to do that again. I'm going to have to do this power reduction formula thing again. All this other stuff is not bothered though. 1/4 plus 1/2 cosine 2 theta, and then 1/4 is not bothered, but I've got cosine squared 2 theta that I've got to do this. Now, here's the thing. What do you notice about the theta going from here to here? What happens to it? It doubles. So that means that if I have cosine 2 theta in here, over there I'm going to have cosine 4 theta. So this thing right here is going to become 1 plus cosine 4 theta over 2. And then all I've got to do is go back and simplify. So I've got 1/4 plus 1/2 cosine 2 theta. When I bring this 2 out front, that's multiplying this by 1/2, so I get 1/8. And when I distribute that through, I'm going to get 1/8 times the 1 gives me 1/8. And 1/8 times cosine 4 theta is 1/8 times cosine 4 theta. And then of course you can simplify this. You can combine the like terms here and here. These are not like terms because their angles are not the same. So you end up with 1/8 and 1/4. So that's going to be 3/8 plus 1/2 cosine 2 theta plus 1/8 cosine 4 theta, and that's simplified down as much as you need to. All right, and the half angle formulas, the last ones we're going to look at. The plus or minus symbol, one thing you need to know, the plus or minus symbol in each formula does not mean that there are 2 possible values. It means that you've got to choose and determine the one that's going to be true. In other words, it could be a positive value or it could be a negative value. You determine what quadrant it would fall in, and then you know where the theta over 2 is going to lie as far as positive or negative. All right, now keep in mind as you work with the half angle formulas that the sign outside the radical is determined by the half angle alpha over 2, not alpha. By contrast, the sign of cosine alpha, which appears under the radical, is determined by the full angle alpha. So make sure this is determined by this angle, and the sign of this thing is determined by that whole angle. Alright, so with this one we're going to find the exact value of the cosine of 112.5 degrees. Well, 112.5 times 2 is 225. So if this is my alpha over 2, I multiply both sides to get alpha. So that means that my alpha is 225 degrees. So the cosine of 112.5 degrees is equal to plus or minus the square root of 1 plus the cosine of 225 alpha over 2. Now when I go to simplify, I know the cosine of 225 is one of the 45s, so it's the square root of 2 over 2. And in the 225, it's going to be in quadrant 3. So adding a negative is the same thing as subtracting square root of 2 over 2. And it's still all over 2. Now, what do I know about 112.5? What quadrant is that in? Well, it's going to be in quadrant 2. And what do we know about quadrant 2? About cosine. Is it positive or negative? Well, since cosine's x values, 112.5 degrees is going to be in quadrant 2, which is going to make that a negative. So that means we're going to have minus the square root. Now we think about this one right here as 2 over 2 minus square root of 2 over 2. So we end up with 2 minus the square root of 2 over, keep, change, flip. I'll step that to one more step before I do that. So that whole thing is under the radical. When I keep, change, flip, I'm going to multiply this thing by 1/2, which is going to give me negative square root of 2 minus the square root of 2 all over 4. And I can split that up. If you remember, the square root of the top, square root of the bottom. So that's going to be the square root of 2 minus the square root of 2 all over the square root of 4, which is 2. And that's as simplified as you would go right there. Alright, so for this one we're going to do a little bit of verifying. This one definitely want to start with the right side here. Tangents just, the thing is you don't want to start with the simplest side in this case because you really don't know which way to go. You want to start with sine over cosine and try to work it into this. It's a lot easier to use what you know about cosine 2 theta and sine 2 theta and work back to tangent. So we're going to deal with this side. And we've got 1 minus cosine 2 theta over sine 2 theta. Now, one of the things I'm going to do here is I'm going to mess around just a little bit just to see if I can be led a little bit. The easy one to choose. The reason I don't want to do anything right in this first step with the top is because how many different versions do I have of cosine 2 theta? I've got 3. And I don't know which one I want to use. So I'm going to do just the bottom one because I only have one of those. Only one thing equals the sine 2 theta that I know. And I'm going to see if it kind of tips me off to what I need to do up there. So we're just going to leave the top like it is for now. 1 minus cosine 2 theta over sine 2 theta, which is 2 sine theta cosine theta. Now remember, I'm trying to get this thing to equal tangent. And tangent, of course, is sine over cosine. So I'm going to need this, and I want to get rid of this sine and this 2. So I think I'm going to take this and use the thing that says cosine 2 theta equals 1 minus sine squared theta. That's going to make more sense than bringing another cosine in here. I don't want the cosine, and I want to get rid of this sine. So let's try that. So we got 1 minus cosine 2 theta is going to be replaced by this thing. 1 minus sine squared theta. Don't forget, you want to put that parentheses so you don't forget to distribute this minus through. And then I've got 2 sine theta cosine theta. Alright, so on top I'm going to have 1 minus 1, which goes away. I'm going to have 0 minus a negative sine squared theta. So I'm going to have sine squared theta. Sorry, that should be 2. That should be 2. I keep missing those. I've done that before a couple of times today, actually. So I've got 2 sine squared theta over 2 sine theta cosine theta. So the sine theta here is going to cancel out with one of those. The 2's are going to cancel out. And what am I left with? I'm left with sine theta over cosine theta, which is tangent theta, and I have confirmed, I have verified the identity. Alright, now here are a couple of formulas that you're not going to use very often. You need to write them down, you need to have them for the test, but you're not going to use them that often. But they're plug and chug just like everything else, so just know how to use them if you need to. And here are all the formulas that you're going to be able to use on the test from a sheet. And that's all of this section.